Hello, part 3, our lecture. So now we want to go from Y to the principal stress. Now Y down here correspond to Y on the element here. So how to go to the principal stress is we have to rotate anti-clockwise by what we call 2 theta p. So you can do from Y, you can do from X, is the same thing. Alright, so like what I've taught you guys before. So tangent 2 theta p will be the this distance. Alright, so this the distance from here to here. Hold on. So it's this distance over here. Alright, so this is our shearing stress, and then is the distance from here to here. Right, so this corresponds to 13.25. The other one corresponds to 28.267. So 13.25 divided by 28.267. So 2 theta p over here will be equal to 13.25 divided by 28.267 with tangent is equal to 25.1 degrees. Anti-clockwise, and theta p is 12.6 degrees. Again, anti-clockwise. So the carbon fiber orientation optimum orientation is 12.6 degrees anti-clockwise, and 90 plus by 12.6, which is equal to 102.6 degrees anti-clockwise relative to the, so for our case, relative to the x-axis. Right, so once you have this information, this is critical. Well, so what does this actually means now? Okay, so you have this angle, this is a carbon fiber optimum orientation. What does this actually means? Okay, I'm going to show you how are we going to relate this in real life. Right, so we look at our shaft. So we're going to view our shaft in the what we have over here. So we're going to view this again from the plan view. Okay, we're going to view from the plan view. So I'm going to shortly construct this on our plan view. Okay, so you go over here. So this is our plan view, and I'm going to draw where element H is. Okay, so don't worry. So this is our plan view, right? So this is our, this will be our X, Y. Okay, so this is our axis. So we have, remember, we have our element. Right, so this is our element. So we find that we have to rotate anti-clockwise by 12.6 degrees. Okay, so So this is 12.6. Okay, so 12.6 degrees is somewhere about here. So this is your first laying orientation of your carbon fiber. Okay, so I'm going to change color. So 12.6, I'm going to make it 13. Cannot get 12.6 already. Okay, so this is the first lay direction. Okay, so this is our first lay direction. Oops, sorry. Alright, so that's our element, that's our first lay direction. So this will go by 12.6. Okay, so this is our number 1 lay, and we're going to lay it 5 times. So it will travel 5 times. Okay, one end to the other end, then come back again, one end to the other, then 5 times. And then the next direction we will get it to lay, right, like what we mentioned before, is, so I'm going to paste, and we're going to rotate this, the component, or not the component, the device, to lay the carbon fiber in this direction now. Okay. So this is our lay number 2. Okay, and then we're going to lay 5 times. And this is because we lay this way. This is because we are orientated on the principal plane, right? So 0 shear stress. But we cannot just lay in this direction, just this direction. So the next lay number 3, excuse me, we're going to lay in a direction that is our non-principal plane. So we're going to rotate it by, okay, by a certain degree. So for this case, I take it 5 degrees. Right, so 12.6 plus 5 is 17.6. So the next lay direction that we're going to do is 7. Okay, so we're going to say, or you can plus 10 degrees, arbitrary numbers. Okay, so it's going to lay this direction. Okay, so the third lay is in this direction. Okay, so number 3 lay. Okay, you lay it, but maybe you lay it once. Okay, and this will be 12.6 plus theta, or delta theta. Right, so you decide. You decide on delta theta. Okay, it can be either 5 or 10 degrees. You decide, arbitrary numbers. Okay, then your lay number 4. Again, come back. Okay, then we're going to rotate 90 degrees. Okay, so this is your lay number 4. Again, is going to be, so this is your lay number 4. Okay, lay number 4 times 1. So it's going to be the principal. So this will be, sorry, the first time I did not write the angle over here. So this angle over here, 90 degrees, Okay, so this angle over here, do apologize, is where you have 102.6 degrees. Okay, so lay number 2 will be 102.6, or lay number 4 plus by your delta theta. Okay, oh, change color. Okay, so 102.6 plus by your delta theta again. Okay, again, delta theta is you decide. Okay, whatever you. Then the next one, the lay number 6 of 1, 2, 3, 4, 5. Okay, so I'm going to copy this again. So as we proceed, all right. Alright, so as we proceed, oops, sorry. Then we go on to lay number, we're at lay number 5 now. So lay number 5, okay. So number 5 lay is going to be at the principal plane again. Okay, so number 5 lay is, we're going to again coming back to here. Coming back to here. This is my lay number 5. Number 5 lay times 5 times. Okay. And then I'm going to follow into here again. Number 6 lay times 5 again. Okay. And then you follow on your number 7. So what you do by number 7 and number 8, so we are progressive adding more now. Okay, so you do your next one. So you do your next lay direction. So you can, is again, you decide. So the next one will be somewhere around here. Alright. Somewhere around here. Alright. So this will be lay number 7. Number 7 lay times 1, because you are not in the principal plane, and this is based on 12.6 plus by 2 delta theta. Okay, again you decide what is delta theta, and then lay number 8. Okay, you go over here and you do it again. So this is your lay number 8. Lay times 1 will be your 102.6 plus by 2 delta theta. Okay, so I don't think you can see the 2 very well. Sorry. So this is 2. Okay, 2. And you carry on so on and so forth till you finish laying. Now let me elaborate why knowing the shear stress orientation is critical. Okay, I'm going to elaborate, especially for carbon fiber. You got this wrong, you're going to ruin your reputation, and you're going to ruin my reputation. Okay, so oh, look at the circle. Bloody hell. It's ugly. I'll draw it again. I think it's because my computer is just too overwhelmed with information now. It's just too hot. Okay, so my bad. So whenever the temperature is too high, you usually get this effect. Okay, so I'm going to copy this whole thing. Let's say we get the shearing stress direction wrong. Okay, so this is the right one. Copy. I'll come down here. Okay, I'm going to paste. Right, I'm going to copy the whole thing. Oh, come on. I'm going to show you shortly. So now, what if we have got this wrong now? Okay, so we got this wrong. Okay, so this is the value. So I'm going to use the red for the wrong one. So let's say we call this our point X, and now this is our point Y. Okay, so red means wrong, point X and point Y. So we say, okay, we are good to go. Okay, we know our orientation, so we draw this. So now the problem now is we say that, all right, we will be very sure, and you're not my student. You say, okay, I know the optimal angle, we are good to go. And it's going to be, what direction is this now? Clockwise. So when you lay your shaft now, right? So I'll show you the right. So I'll show you the right direction. So this is our shaft now, right? And then all hell break loose. Okay, so this is our element, right? This is our X, and there's our Y. I'll draw the correct one again, the valid one. So the correct one to lay, this is the centroid or neutral axis. The correct one to lay, I'll draw in blue. Okay, is this orientation. This is the correct direction. Okay, so this is your correct direction. So 12. Wait, it's not 12. I forgot what direction. 12.6. Okay, so we declare that this is correct. So we lay out fiber. Right? So this is the valid direction. Okay, so 12.6. Okay, anti-clockwise. This is correct. I'm going to do it in red. If it's wrong, how will you lay? Okay, so I'm going to paste. I'm going to change this to red. Oh God, not a good idea, I think. Okay, yeah, not a good idea. Okay, what I'll do, I do apologize, mocking around on the wrong thing. I will cut. Okay, so we draw in red, the wrong direction. So I'm going to do parallel. Okay, and this is wrong because why? We say that this is the principal stress direction, right? Clockwise, 12.6 degrees, right? It's not even our principal stress direction at all, and this is invalid. We are laying at an arbitrary angle, and we just do times 5 lay. Okay, not even laying on the principal stress. And when that happens, yeah, if it's just for commercial use, fine. But it's for aerospace or even for motor racing, you're going to be in trouble. Okay, your laying direction is all wrong, and you assume that you have optimized your angle. In fact, you have not. Okay, so this is where knowing your principal stress is so critical for carbon fiber. So this is the end of our series on how to design with carbon fiber. Next video will be on metal cutting. Thank you.